Here's a typical titration problem. We're going to start by calculating the concentration of the standard solution that we used, and we can do that by using the formula concentration equals number of moles over volume. We're going to have to work out the number of moles because we're given a mass at the top of the problem. So you can do that using the formula number of moles equals mass over mR, and we take on 0.75 grams and we divide it by the mR of sodium hydroxide, which is 40. So that gives us 0.01875 moles of sodium hydroxide in our solution. Now we need to find out the volume. Unfortunately, that's given to us in millilitres in the question, and we can't plug those into our equation, so we have to convert that volume into litres before we can put the value in. So 100 mils equals 100 over 1,000 litres. We always divide by 1,000 to go from millilitres to litres. So that's 0.1 litres of sodium hydroxide. So now we can plug both of those values into our equation. So the concentration of our sodium hydroxide is 0.01875 over 0.1. And that comes out as 0.1875 moles per litre. And you'll notice that we use -3 to represent per litre. So that's the concentration of our standard solution of sodium hydroxide. Now we want to start to think about our reaction. We took a small portion of the sodium hydroxide, 20 mils, and it was neutralised by 17 mils of hydrochloric acid. So here's the equation for that reaction. We're being asked to calculate the concentration of the hydrochloric acid, which is given by the number of moles divided by the volume. Now we have the volume, that's given to us in the question. We need to work out what the number of moles is. As we can see from the equation, there are no numbers in front of the sodium hydroxide or the acid. So that tells us that the number of moles of hydrochloric acid is exactly the same as the number of moles of sodium hydroxide we used, i.e. the number of moles which was in the 20 ml portion. So if we work out how many moles are in the 20 ml portion of sodium hydroxide, we'll be able to work out the concentration of the hydrochloric acid. So we can use our equation again, number of moles of sodium hydroxide equals the concentration times the volume, which in our reaction was 20 mils. That's how much we pipetted into our flask. 20 mils equals 20 over 1,000 litres, which is 0.02 litres. So the number of moles of sodium hydroxide we used equals 0.1875 multiplied by 0.02, and that gives us 0.00375 moles. Since it's a 1-to-1 ratio, we therefore had 0.00375 moles of acid in our 17 mils. So now it's just a matter of using our equation again, this time on the acid. So the concentration of the acid was number of moles divided by volume. We need to convert our 17 mils into litres again before plugging it into the equation. So that's 0.017 litres. So concentration equals 0.00375 divided by 0.017. That comes out as a big long number on our calculator. Now if we look at the degree of accuracy to which we were given values in the question, most of them are 3 significant figures, but the mass of sodium hydroxide is only to 2 significant figures because the 0 doesn't count. So we can't really give our answer to any more than 2 significant figures, because how could we be sure that it was correct? I'm going to change the colour of my pen. For the examiner, you want to make it really clear what your final answer is. So the concentration of the acid was 0.22 moles per litre.